So this video is going to show you how to prove that you have a rhombus. So I've already graphed the rhombus in number 1. In order to do that, if you look at the flow chart at the top of the page there, you can see that a parallelogram branches into a rectangle, a rhombus, and a square. Because of that, for those 3 quadrilaterals, you have to first prove that they are a parallelogram. So therefore, I'm going to first show that this rhombus is a parallelogram. How do I do that? Well, in a parallelogram, opposite sides are parallel, which means they have the same slope. So we're going to find the slope of all 4 sides and show that the opposite sides are parallel. Okay, so the slope of DC is what we're going to do first. Formula is y minus y over x minus x. And when I do this, I'm going to do, I'm actually going to do point C first. So I'm going to have 6 minus 5 over 8 minus 5. So on the top we get 1, and the bottom we get 3, 1/3. Now let's see, DC should be the same as AB, so let me do that one next. So AB, okay, y minus y, so 2 minus 3, then x minus x, 4 minus 7. Top, we're going to have a -1, the bottom a -3, but a negative divided by a negative is positive 1/3, so you can see the opposite sides have the same slope so far. Now let's keep on going. You have to do all 4 sides. I'm going to do DA next. Okay, I'm going to do actually AD. Like I like looking at A first. Okay, so 2 minus 5, and then we have 4 minus 5, so we get a -3 divided by a -1, which is a positive 3. And last side is CB. CB, I'm going to look at B first. So I have 3 minus 6 over 7 minus 8, which gives you a -3 divided by -1, which is a positive 3. So you can see that opposite sides are parallel because they have the same slope. Thus, it's a parallelogram. Okay, this is about half the problem. Now we have to get more specific and think, well, what do we know about a rhombus specifically? Like, why isn't this just a parallelogram? What makes it specifically a rhombus? And the one thing that sticks out about a rhombus is that all 4 sides are congruent. So that means they have the same length, which means we can use the distance formula and show that the length of the sides are the same. Now, you don't actually have to do it for all 4 sides. You really just have to do it for 2 sides that are next to each other, which are consecutive sides. So if I do side, let's say, DA, I just have to make sure I do a side right next to it. So I'll do AB. Consecutive sides have to be congruent. Okay, so we're going to use the distance formula. And we're going to do it 2 times. How about we do it first for DA? So big square root, right? And then it's parentheses x minus x squared. So I'm going to look at point A first. So that would be 4 minus 5, all of that squared, plus, and then it's y minus y squared. So parentheses, and I have to go back to point A because that's what I started with. So it's going to be 2 minus 5, close the parentheses, squared. And when you do put this in the calculator, you are going to get 10. So it's radical 10. So now we're going to do a side next to it, and we should get the same thing. So I'm choosing to do side AB. So again, we're just going to plug it into the distance formula. X minus x squared would be 4 minus 7 squared plus y minus y squared, and again, you will end up getting the same thing, radical 10. So we can see that it's a rhombus. So when we write our conclusion, we're going to say the first part that we proved was a rhombus is a parallelogram, right? That was using the slope formula. So we're going to have to do that for a square as well. And then making it more specific towards our rhombus, we're going to say with, now I'm going to talk about what the distance formula proved, with 2 consecutive, meaning next to, with 2 consecutive congruent sides. 2 consecutive congruent sides. They both turned out to be radical 10. So number 2 says that we have square GEOM, gives us 2 points, G and O, and it says to determine and state the coordinates of vertices E and M, then we have to prove it's a square. So first let's make that square. Oh, where'd that stray mark come from? Hold on, gotta erase. Okay, so the ordering of the letters does matter for the square because if it's GEOM, that means that those letters have to go in order around the square. You can't just skip around when you have these letters. So if you look at what we have G. Okay, now E could be you know, like somewhere over here, and then go around to O, and then M could be like someplace around here. Well, we have to find that exactly. First step, find that is really a diagonal of the square then. So first thing I did was I found the midpoint of that segment. And you can do that simply by counting. What I did was I counted from O to G. So to get from O to G, you go down 1, 2, 3, 4, and over to the right 6. Well, if I went down 4 over 6. If you just do half of that, I have it up on the top. Really, you're finding the slope there. I would just do half of that for the midpoint. So divide by 2, divide by 2. It's really, I go down 2 and over 3. So that's where that point came from. Okay, now we need to get the other diagonal of the square going like this so we can get those the two other vertices. So what you want to do is, well, you have to know one of the properties of a square, which is that the diagonals are perpendicular. So that means that whatever the slope is of this diagonal, that the slope of the other diagonal is going to be the negative reciprocal. Well, we've actually already found the slope. If you look at right here, that line, the slope is negative 2 over 3, right down 2 over 3, do the negative reciprocal. Okay, so I'm going to flip it. I'm going to make it positive. 3/2 is going to be the slope of the other diagonal. So go to that midpoint and just count up 3, 1, 2, 3, and over 2. There you go. And then you want to keep going this way though, because you want to get that other point. So if it was up 3 and over 2, and I want to add a point over here, I would just have to go down 3 and over 2, and right here. So those are the coordinates of your square. So let's see, if it's GEOM, it would have to be GEOM. So actually, you could have gone the other way as well. Looking at it, you can want GEOM. It wouldn't make a difference, and your work would turn out to be the same. But I'm just gonna pause this video so I can make nice lines when I connect to form the square. Okay, so I connected the other diagonal in there as well. Let's write down what the vertices are for E and M, because when we go to use the formulas, we have to know that. So E is 1, 3, and M is, let's see, M is -3, -3. Okay, how do we prove it's a square? As we talked about before, I wonder if it's still up here. Yes, it is. See how the square branches off from the parallelogram? So again, when you prove a rectangle, rhombus, or square, you first prove it's a parallelogram, just like we did. So this whole section up on the top, opposite sides are parallel. We're going to do that same thing for the square. So that's not going to change. Okay, so we have to find the slope of all 4 sides. All 4 sides. So OE is what I'll start with. So what do we have here? Y minus y over x minus x, right? I'll put the formula once. Okay, so we have 3 minus 2, and then I'm going to go back to the point I used before. So 1 minus a -4, so really plus. So we get 1 over 5. So that's the slope of OE. Okay, so let's do the slope of OE. How about MG? Because that one should be the same. Square is the longest one to do, involves the most amount of work. Okay, so MG, let's see. So -3 minus a -2 links to plus. And we have a -3 minus 2. And we get a -1 over -5, but a negative divided by negative is positive, so you can see how they're both 1/5. Okay, let's keep going. Slope of next we'll do MO. And let's see, M, okay, so it's -3 for the Y minus, and the O it's 2. And then -3 for the X minus, a -4 leads to plus. So we have -5 over 1. One more side, the slope at least. Next is EG. Okay, EG, where's E? All right, 3. Minus, and then in G we have a -2, so it's plus, and 1 minus 2. So we have 5 divided by a -1, which you can reduce down. Let me do that. So this is really -5, this is really -5. So you can see it's a parallelogram because the opposite sides are parallel. We have the 1/5, we have the -5. Okay, what else do we have to do? I think of it this way. If you go all the way back up, okay, so we proved it's a parallelogram. Let me cross that off. You really are proving it's a parallelogram, a rectangle, and a rhombus. So let's do rectangle next. How do we prove that we have a rectangle? Well, in a rectangle, we have 4 right angles, and don't we have that in the square as well? Remember, right angles give you perpendicular lines, and perpendicular lines, the slopes are negative reciprocals. Well, we already have that, right? Look at consecutive sides. Let's say MG, EG. Okay, so MG is 1/5. Look at the slope of EG, -5. They're negative reciprocals. So your work is already there proving that it's also a rectangle. It's just that when we have to make sure we write that in the conclusion. Okay, so we did rectangle. That's already there. Last is rhombus. How do we prove it's a rhombus? Well, let's look at what we did here. We already have all the slopes, but towards the bottom, remember we found the distance of 2 consecutive sides? That is showing that it's a rhombus because the 2 sides next to each other are congruent. Well, we're going to have to do the same thing here. Take any 2 consecutive sides. How about we do OM and MG? And if we show that the distance is the same for those 2 sides, well, then that also makes it a rhombus, which means we'd have the work for a parallelogram, a rectangle, and a rhombus. And all 3 of those pieces put together make a square. Okay, so I'm going to find the distance of, it's a big square root formula. I'll do OM. I'm not going to write the formula. I'm kind of running out of room here. But let's see. Where's O? So -4 minus the -3, x minus x. And then y minus y. So 2 minus -3, so plus again. Okay. And remember, you put it in the calculator, just don't type the square root. And when you do that, you end up getting a 26. So it's radical 26. And we have to do a side next to it, consecutive to it. So I'm going to choose to do MG. Okay, let me write this part out. Okay, MG. All right, so we have, I'm going to start with M. So I'm going to go -3 minus, and I'm looking at G, which is a 2. And then I'm going to go back to M, -3 minus, let's see, G is a -2, so it's plus. Again, put in the calculator, and you'll get a radical 26. Okay, so although the work looks the same as a rhombus, the conclusion is going to be different. So, therefore, a square is a parallelogram. Remember, we showed that because opposite sides are parallel. And then we have to talk about basically what made it a rectangle and what made it a rhombus. So remember, it was a rectangle because the consecutive sides were perpendicular, right? We had 1/5 and -5. So it was a parallelogram with consecutive sides. And this is all in your chart. Everything's in your chart in case you forget what to do. With consecutive sides that are perpendicular, I'm going to use the symbol. And what else did we show about those consecutive sides? Well, the rhombus portion of it was we showed that the consecutive sides had the same distance, radical 26. So that makes those 2 consecutive sides congruent. So the consecutive sides were perpendicular and congruent.